Hey guys, so I'm going to basically walk you through the homework assignment for this week. The numbers are a little different, so you won't have the exact same values. Don't worry about that. I changed the numbers on purpose, but it won't affect the way that you do this. So the idea behind the homework is you've dropped a ball off a tall building and you record how long it takes for the ball to fall and hit the ground. So the time that it takes for the ball to fall is recorded over here in column B. And what we're going to do is we're going to find the average time. And the way we do that is we say equals average, and then we select that entire column. So our average time that it took the ball to fall was 10.54 seconds. Cool, so from there we can find the height of the building. In class, I said, remember, we're starting the ball by dropping it from a standstill. So the v0 term in the velocity equation is 0, which means that this goes away and this term goes away. And then we also said we can say y0, this value here, is also going to be 0, so this goes away. So that simplifies the equations we're going to use even more. So the prompt that I gave you for the homework is I want you to find the height of the building, and then I want a plot of velocity versus time and position versus time. So the way we're going to do that is we're going to make essentially another table where we have time, velocity, and position. So we know that the total time it would take the ball to hit the ground is 10.54 seconds. So we're going to make time points from 0 up to that time. And it's okay that you don't have to fill them in completely evenly. We just want to get enough points to get a smooth curve of our graph. So I went from 0 to 10, and then also filled in the last time of 10.54 seconds. So if you look down here at our velocity equation, since we said that our initial velocity is 0, that just means that our velocity at any given time is just equal to the acceleration times that time. So the way we're going to do that inside our velocity column equals acceleration times time, and hit enter. Actually, before we hit enter, the acceleration term should be locked. So we're going to lock that term and then hit enter, and then click and drag it down. So that means by the time that the ball hits the ground, it's traveling 103.3974 meters per second. Now we want to also find the position of the ball at any given time. If you look at our position equation, since we said that our initial velocity is 0 and our initial position is 0, the only thing we care about is this term right here, the 1/2 times acceleration times time squared. So the way we're going to do that is we're going to go over to our position column, say equals 1/2, or I'm going to type in 0.5. 1/2 and 0.5 mean the exact same thing, times our acceleration term, and again, we need to make sure that that value doesn't change when we drag our formula down, times time squared. And you can either do that by saying times cell and multiplying it by that cell again, or you can hit the caret and 2. Both of those do the exact same thing. Hit enter and drag it down. So we found that the total height of our building was 544.9 meters tall. That's a really tall building. And then I want you guys to graph this. I want a graph of velocity versus time and position versus time. So if I go here, select it, and then hit Insert Chart, it shows my velocity versus time. If I go and select these columns, and the way I selected the columns that weren't continuous was by hitting the Control button, Insert Chart, I got my position versus time.